So the instance belongs to that class, and else it just it predicts that it does not. That is, it belongs to a negative class, right? Which is labeled as 0. So this makes it a binary classifier mostly, right? So anyway, we will deal with. So basically, it gives us a probability. If the probability is the what kind of probability? Probability that an instance belongs to a particular class, right? And if the probability is greater than 50%, then it belongs to one particular class, say the positive class or the level 1 class, okay? Or if it predicts that it does not belongs to that particular class, then it belongs to the negative class, right? Or labels as 0, okay? Acha. Now loading the data set. So we will deal with a data set called Cleveland heart disease data set, okay? So Cleveland heart disease dataset has few features, at least 13 to 14 we can see here. So what are the attributes? One is age in years. So some for some patient, then there is 6. Whether if it is 1, then it is male. If it is 0, then it is female. Then CP, which denotes the chest pain type. Then another one is stressed BPS, right? Right. So TREST BPS. Stressed BPS, which is resting blood pressure. So, and what is the blood pressure? So, in high blood pressure above 130 to 140 is typically cause for concern. Okay, then the other one, then the next one is CHOL or CHOL. So, serum cholesterol. So that spelling is wrong. It should be cholesterol in milligram per DL. Okay, and cholesterol above 200 is always a cause for concern, right? Yeah, so above 190 also is quite 200 to 250 as far as I know is a high amount of cholesterol. Anyway, FBS, the next term is FBS. FBS is the fasting blood sugar. Okay, blood sugar again above 120. Fasting, fasting blood sugar above 120 is FBS. So it should be FBS, which is more than 120 mg per DL. Okay. Then rest ECG. So rested in resting position. What is the ECG signal? 0 is normal. 1 is having ST wave abnormality. So 1 is okay. 1 is basically abnormal ECG graph. 2 is showing probable or definite left ventricular hypertrophy by STS criteria. Anyway, so 2 is another some disease. I actually don't know what is the probable or definite left ventricular hypertrophy, but that is not required. Some other class. THAL, SCH, thalate. So that is a I think the heart rate, maximum heart rate which is achieved. Then X-ang. X-ang is exercise induced angina. Okay, so whether that person has angina or not, I think that is the case. So 1 is a yes and 0 is a no. So all are mostly heart disease related things, right? What is old peak? Old peak is the depression induced by the exercise relative to rest. Okay. And slope is the slope of the peak exercise ST segment. Acha, okay. So slope has 3 levels. One is upsloping, downsloping is 3, and other than that there is a flat value. Okay, fine. So slope has 3 levels. X-ang has 2 levels, 1 and 0, and rest ECG also has 3 levels, right? 0, 1, 2. Achha. CA is the number of blood vessels colored by fluoroscopy. Achha. CA is the number of major vessels which are colored by fluoroscopy. THAL, that is THAL is 3 normal, 6 is a fixed defect and fixed defect, 7 is a reversible defect. Achha. NAM target, which is the diagnosis of the heart disease. So 0 to 50% means 0 is the less than 50% diameter narrowing, and 1 means greater than 50% diameter narrowing. Okay, I'll just check what does those things mean in the diameter. Okay, so basically the diagnosis of the heart disease, whether there is any requirement of angioplasty and everything, angiographic disease status. I think that is the case mostly.
So in this case, equality, what happens at 50%? It is not mentioned.
Yes, that is one good point. That is one good point. I think okay, we'll see. we'll see what can we do. Okay, let's go through the reference ones, whether check whether anything is written. So this is the heart disease dataset library. Okay, 1 minute. Huh? Six, where is NumTest?
It is there. It was
This TCG.
scroll down.
Old peak. Then L equals to 3 normal, 6 is fixed defect.
Yeah, here
Value
58.
0 is less than value 0 means less than 50% diameter narrowing. Value 1 means greater than 50% diameter narrowing. In any major vessel, attributes 59 to 68 are vessels. Okay. No, so the question is what happens when there is a in num what happens when there is 50% on equals to 50% diameter narrowing. Okay.
Right.
Acha, equals to 50, I mean almost half of the diameter is narrowing.
So basically, to which class it will belong?
Yeah, I think it can, we can take it in any
We can't.
yeah, in particular the Cleveland is only.
I think we can move forward. Like, but yeah,
1 minute, 1 minute, 1 minute. It is integer value from 0 to 10. Experience with Cleveland database as constant. We actually need to check the paper. Dash application of a new probability algorithm. Okay, let's get on. We'll see. Okay, I think in these 3 papers we have to check what happens if there is equals to 50%. Okay, I think
Yeah.
that will be based on a, I don't know, based on case to case basis we can see or something. I don't know. I mean, let's check. Let's go move forward. We'll see. Okay. So anyway, what we do is we import.
Sorry, Divajit, you can. I found it. Go to the paper. Go to the page.
1 minute. 1 minute. That's a good thing. 1 minute. 1 minute.
Same page.
1 minute. Huh?
I'll just send a link in the chat if that helps.
Yeah, sure. Let's see.
Yeah. So just keep scrolling until you reach number 58 in the attribute documentation. Up 58. Look at 58.
58 is NUM, right? Diagnosis of the heart disease. Huh?
And that value 0 and value 1 are the classes.
Huh?
That is the question, right? Like, how do you?
No. The question is what happens when it is equals to 50%. The question is
okay.
Well, yeah. I think in this the 3 papers we have to read basically. Okay. Yeah. This.
Do they have any values that are exactly equal to 50%, or they have not encoded them that way at all?
I don't think so. I don't think so. But let's see if we find it. We'll inform it. Okay. Yeah. Yeah, basically we have to, I think 1 or 2 these 3 papers we I have to look into, and we can find it from there. So anyway, first of all, obviously we import basic libraries, right? So we import pandas and we import matplotlib, and yeah, Amruta is here. Amruta, do you remember what happens if it is equals to 50%? Just let me know in the chat window if possible. Anyway, we import basic libraries. Then what happens is that we are downloading the data set, the heart disease data set from, I'll just do one thing. I'll copy the link in the chat window also, so that you can carry on with us. Okay. So I'll copy the code here. Okay, so you can write it directly in the collab, and you can start with it. So one thing is that we are importing pandas as PG and importing matplotlib as PLT.
So I have one doubt regarding that same question.
Yeah.
So this is a classification problem,
Mhm.
and we have labels,
Mhm.
which is saying label 1 is the artery is narrowing by more than 50%, and label 0 is when the narrowing is less than 50%. Okay.
Mhm.
Now, in a logistic regression, we go for a threshold, right?
Mhm.
When we label, I'm saying for prediction.
Mhm.
For prediction, there's a threshold, maybe 50%, whatever you set the threshold as.
Mhm.
Now, in that threshold, if we mention, say, greater than, and we don't put equal to, then there's a problem in prediction. But in the threshold, if we have greater than equal to, then it will label it in 1 or 0.
If you put as so basically you are telling
threshold,
that if you are telling
here it will not matter greater than equal to, because we are not doing a regression, we are just labeling it.
no, but still
That's my understanding, because here I'm just labeling it. Now in the threshold, if I say greater than equal to 50%, then it'll label as, then I can say it'll label as 1.
So anyway, I mean, there can be some cases where there is equals to 50% diameter narrowing, right?
See, there would, like the previous speaker said, the data is giving labeling just like this. Less than 50%, greater than 50%. Now let's say this is a label. This is not a feature, right? It is not a feature. So in my prediction also, I'm predicting a label. So the label prediction will be by the threshold, not by any feature, you know. I mean, I don't see the relevance unless the threshold is not specifying greater than equal to and less than equal to. There shouldn't be a problem in labeling it.
No, I mean, yeah, that is the basic question is what happens at the threshold. Yeah, so one thing which can happen,
if we go ahead and we can see how the threshold is defined when we come to it, then it'll be clear, I think.
Yeah. Let's see. I mean, I'm also not sure what happens. I think
Why does this matter? Because in the data set itself, they are giving us straight away 0 or 1, right? They are not giving us any scalar value. So our training data, the training targets themselves are just 0 and 1.
Yeah,
that's
exactly what I meant. Yeah.
Anyway, let's see. I mean, if it is there, we'll find it. Okay, let's see. Okay, so the basic libraries which we are importing is pandas and then matplotlib .pyplot as PLT, cbond, then numpy as NP. So before that, so from data sets we are importing, right? From header equals to none. No. So from sklearn we import data sets, and from sklearn.linear model we are importing logistic regression, and from pandas.plotting we are importing scatter matrix, simple imputer, and standard scalar. I'll just copy whatever we are doing in the chat window so that can you guys copy from the chat window? Then I'll
no, sir, I'm not able to. It's I don't know the why.
You are using a computer, right?
Yes, sir.
Okay, anyone else has this problem that you can't copy from the chat window?
Even I can't.
Okay, we could actually do with the okay. I mean, I would give the code here. Okay, anyway, fine. Then I mean, what? Okay, let's go ahead. We'll see.
We can see. Can you try selecting the text and right click and copy instead of Control C?
Who, me, Amrita?
No, in the chat.
I tried
box.
right click only. I tried right click and I only see select all. No other option.
Same here. Same.
Yeah, we need a. Can you share the same in a Google Doc?
So it works
Yeah,
if you join the Zoom meeting from the browser instead of using the app.
Okay. Yeah. Interesting.
Sorry, what?
Yeah, I have joined from app, so he's saying like if we join through browser rather than the app, it works.
No, I'm from the browser.
Okay. Okay, let's do one thing. Let me just one moment, huh? Let me see whether that thing works, whether it can share in a Google Doc or somewhere, so that you can do it. Okay, 1 minute, huh? 1 minute, just 1 minute. Let me make a Google Doc. Just 1 minute. Because otherwise, if you also do not do, then it doesn't make much interesting. Can you check whether you can access this document, this doc? I'll write something here. Yes, I think many of us can access.
Yes, I can.
Yes.
Yes. Now let's start. I mean, whether, yeah, otherwise, I mean, it doesn't look good. I mean, I am just telling and you are just.
So can you
listening.
paste the previous code also?
Yeah. Wait. I'll start again. I'll start. 1 minute, huh? So, first of all, what is the reference? Let's start from the reference. So this is the UCI EML database, right? So first of all, this one goes. Then what else is there? Then we are importing basic libraries. So this is the import. This one. So this is the PD, the pandas, and you can copy from here, right? Link of the doc. Yeah, it is here in the chat window. Himanshu, just above you. I'll just put the chat in the chat window, the link again. Okay. Yeah. So then what are we doing? We are just downloading the heart disease data set. So we are defining the column names. So what are the column names? We have age, sex, then CP. CP is what? CP is the chest pain type, right? Then we have traced BPS, cholesterol, FBS, race TCG, thal ECH, exangina, etc. etc. So the next target is to load the data set, right? So then the next target is loading the data set. So here, first target, what we are doing is to define the column names. And what are the column names that we have? Age, sex, CP, traced BPS, CHOL, thal, NAM, etc. etc. And then we are loading the data set. So sorry, this is heart data, right? Yeah. So heart data, and from where we are reading the CSV file, https archive.ics, and so this is the heart data. So, and after once we load the heart data, what we are getting the collab, right? Sorry, the full data set, right? Okay. So up to 302 we have, from 0 to 302. That means 303 rows into by 14 columns, right? Now, what is the data type? So we are checking the type of the data variable. So again, if you just let me copy it here. So we are checking the type of the data variable. Then that is data frame, which is coming as data frame, right? pandas.core.frame, the data frame. And just to get an idea of the elements in the data set, we are displaying the first 5 rows of the data set. Hard data, head, okay. So we have again just code to write the codes, okay. This is our first 5 rows. This will give us the first 5 rows, right? And apart from that, what we have, then again we can do the last 5 rows as well, right? So head determines the first 5 rows. Head is first 5 rows, and tail is last 5 rows, right? Tail is last 5 rows. So again, if we just let me write it here, then hard data dot tail, tail is the tail and all we have done. So basically we just got an idea of how the data set looks like. And then some more, we have to visualize the data set. Again, this is important because we have our OPPs coming, right? So a histogram and other things are may come very soon. So we are visualizing the data sets. So these are the different data sets which are getting generated. We have a histogram of different features, right? So for different all the features, we are running a for loop, right? So for all the features in the columns, we have pandas as PD and matplotlib.pyplot. We are importing as PLT, right? So what we have is PLT.histogram, and histogram of what now? Of the hard data, and what are we plotting? We are plotting features. After that, what we are doing is we are giving a plot title of the features, and we are showing the plot one by one. We are displaying the histogram. Fine. Up to here, everyone came? Anybody left or could not facing any issues?
No,
Just
clear, sir.
yeah. Thank you. Thanks, Jana. Yeah. Then what are we doing? We are defining the we are doing some pre-processing. Obviously, pre-processing will come. Okay, histogram. Just to say histogram, please look at for your upcoming OPPs. Look at different scatter plot, violin plot, histogram, all the things that are there. Your box plot, as we were telling previously also. Then what you have to do? You have to know what are the how to understand those graphs, how to read those graphs, right? Not only the analyzing or the programming is important. The very important thing is how to steal the story of the data, right? So let's say old peak. So old peak is at around 0. It has a high value, and then it is kind of decreasing exponentially, right? So I mean, telling the story of the data is very important at this time. It looks like. Anyway, let's go and get back to the task at hand. Pre-processing. Pre-processing, we are defining the predefined class labels. So the experiments with the database, what they have concentrated on is simply attempting to distinguish the values 1, 2, 3, 4 from absence, that is value 0. Okay, so what we were seeing here now, that if you go to this data set, so the goal field refers to the presence of the heart disease in the patient. Okay, it is an integer value from 0, which is not at all present. The heart disease is not at all present. Okay, and up to 4. So 1, 2, 3, 4. So experiments with the Cleveland database have concentrated on simply attempting to distinguish the presence of values, that is values 1, 2, 3, 4. So like in cancer we have stage 1, stage 2, stage 3, stage 4, etc. from absence, that is value 0, right? The names and the etc. The things are anonymized and all, which we already know, and in Jaydev and others also know. We are doing with NPTEL, right? Also, anyway, so converting class levels 2, 3, and 4 into a level 1. Again, the binary classification. So basically, binary we have made the class levels 2, 3, 4 all are combined into level 1, and then we are visualizing the levels. Okay, so let's.
So this is not clear. What are we doing exactly?
So it looks like that we are combining all the remaining labels. We have five labels, right?
Five. Okay.
0 is
Yeah.
absent, and 1, 2, 3, 4 are the stages.
Okay. Right.
Okay.
So we are doing 2. Okay. Got it.
Ha, I mean, like that MNIST thing we did, na? That I
Right.
mean 10 classes. Yeah, looks like that. Let us proceed. Looks like that. Okay, so this is the next step. We are we are visualizing the levels at all. Okay. So what happens if we just do that? Yes. So see, we have num, which is 0, and so the last column is 0, 1, 1, 0, 0, and after the last part it is 1, 1, 1, 0. So basically, whether the heart disease is present or is not present, that is the only thing which we are looking at currently. Okay, so for this patient the heart disease is not there, and for the next patient it seems that the heart disease is present. Okay, whatever be the level. So fine, that is done. Then obviously we have the NaN values as always, they are there. So the feature CA has some missing values which are given as question marks, and we are replacing the question mark with NaN, then fill the missing values using mean imputation. So simple imputer mean. Again, obviously this is from week 2. Just put here. Okay. So heart data, we replace the question marks with NP NaN, in place equals to true, right? And missing values to be replaced as NP NaN, strategy mean. Okay. And then fitting with the hard data, fit and transform, fine. And then we are denoting the we are seeing the data frame, right? So whatever be the missing values in CA column, okay, those we have replaced with the mean values, fine. That is also done. Now again, now what we are doing is we are separating the input attribute and the target attribute, right? And so we are assigning a new variable y to the target attribute num, right? So y equals to heart data. 1 minute. Y equals to heart data imputed, and among the hard data imputed is this column, right? This data frame, right? The one which came after the question after the imputation. Then we are targeting the num column of that hard data imputed data frame, and we are assigning a new variable y as a target, right? So again, I'm just writing the code here. Okay. So if we do that, we are getting the y array, okay, which is only the whether the heart disease is present or not. Okay. And obviously from the remaining matrix we are removing the num column, right? Because so we have basically separated the input and the target attribute, right? So remove the target variable from the hard data. Okay.
So this we can do by the drop method also.
I think so. And whatever is remaining, so let us see that. So currently, we see that the num part is not there, or the y is also not there, right, in the hard data imputed data frame. So if we plot it, just let me write also. Yeah. So hard data imputed display. Okay. So currently we don't have any question mark or any not available value, and so all those things are done. Now what we we have also seen histograms of the features. So 12, 13 features are there, right? So all those we have seen, age, sex, and how everything is varying according to that. Those things we have seen. Okay, and all the pre-processing is mostly done. Fine. Let us see what else can we do. We can understand the correlation between the different input features. Okay, so what correlation it can show us? We can plot. How do we see that? How do we see that? We can use the heat map, right? And so heat map is a rectangular. It has a color encoded matrix. An axis level function will draw the heat map to the current active axis. Okay. Okay. So let's plot the heat map as it is asked. This is the heat map part. Okay. Heat map. Okay. So age. Achha, so the diagonal elements are related to itself only, right? So that's why I think all the diagonal elements are columns. The black color squares are all negative values. So they are all at negative correlation, I think. Okay. So anyway, I will check and what more. Can anyone suggest what other information can we draw from the heat map?
Devjyoti, actually,
Yeah.
we are plotting this correlation coefficients, right, between any two features. So first, so it's a matrix consisting of how two features are correlated. So a brighter color will give you high correlation between that feature. So that is why each feature is giving one, a maximum value of 1. So as
yeah,
the
because
color,
they are self correlation mostly. Yeah.
So what we can infer is the minimum value gives the two distinct features. And so those features will be very good for the classification. So if there are minimum negative, that is the 0.39, 0.33.
So
no, but even if it's actually negative, that's also sort of correlation only, right? Like it's very strongly negatively correlated is also something we want to say.
Negative correlation is there.
So take the absolute and then take the minimum.
Okay.
Basically, I think we should see highly correlated features and see if we need to remove them. I don't know if I'm right.
Yeah, we need to kind of merge them or feature out of them.
We can add.
Okay.
Yeah,
so that would be light orange or dark black.
Correct. So they won't contribute much for the classification, right? So that's what we can infer from this correlation coefficient. So this correlation coefficient, I think we can also visualize it without this heat map, but that will be only some numbers. So for visualization purpose, we are using a heat map.
Thank you, Amrita.
Yeah.
Amrita, any idea about the question which was asked in the beginning? So
which one?
They were asking.
I joined
that,
actually late. 5.
Yeah. So what they were asking is the target one, the target column which we have here, the disease status, which is the disease status, whether the heart disease is present or not. So 0 defines less than 50% of the diameter narrowing. Okay. And 1 represents greater than 50% of the diameter narrowing. Okay. So is equals to 50% diameter narrowing important or relevant here? And if relevant, I mean, nothing is there to demonstrate that. So any.
I also have no idea whether what will happen if it is equal to 50% or not. So since they have labeled it, we know only zeros and ones, right? We do not have percentage data with us.
So borderlines are not discussed.
Yeah, they have already labeled and gave us this
Okay.
terms, right?
Yeah, I mean in the website also it's the same is written. We were checking in the 58. I think in the 58. Yeah, value 1 means this is the UCI page.
Yeah.
So here we have value 0 means less than 50% and value 1 means greater than 50%. So anyway, I think these are some medical terms also which we have to yeah pass through.
Yeah, yeah,
Yes.
correct.
Yeah. Okay. Yeah. Okay. Okay. Sure. We'll proceed.
Okay.
So thank you. Thank you, Amrit. So anyway, let's move where we were. Yeah. So now what is remaining is the obviously the next step is train test split, right? So let me write the copy the code also for you. So this is train test split, right? Huh. So then obviously let us do it. So the shape of the training data and what is the training labels, the shape of training labels and shape of testing data, those we have calculated. So in OPP, that is a good step. I think once you do the train test split, check the, you know, the training data shape and the testing data shape once you are, once you do that. And also, yeah, so anyway, there will be questions based on, there may be questions based on those topics. Let's see. Yeah. So it is a good step to, once you do, you can just know what is the shape of the training and testing data, right? So you do a train test. You so just remember the syntax from sklearn.model selection. We import train test split, and then xtrain comma xtest, then ytrain comma ytest equals to train test split. Then what is whatever the data set you are using, comma y, test size. What is the test size? So we are doing 7. Yeah, 75 25, right? Yeah, 75 and 20, 75% is the training and the remaining are the testing, right? And random state will be mentioned in whenever you are trying to do random state. We have, I mean, it is defined here because I mean to get the same answer every time, but random state whenever you are defining in the OPP or everywhere, it will be mentioned that take random state equals to 32, random state equals to 1625, whatever. It will be informed so that the same answer comes every time and everyone gets the same answer, right? Then what is the xtrain? You can just look then type as well. So what is the xtrain? Yeah, if we calculate the xtrain, it is coming as so the training data set part. And so now previously it was 303 and something, right? Now it has become 227 rows and 13 columns only. And as there is a wide variation among the numerical numerical values, hence obviously best practice is to normalize the features, right? So still we are in the pre-processing stage. We are doing a normalization of the features for training. So we are doing a standard scalar. We are applying standard scalar on the data set, on the xtrain data set and xtest data set. So we instantiate the standard scalar to a variable and fit the train test data. So before applying standard scalar, obviously in the beginning we imported standard scalar from sklearn.preprocessing, right? So that is also important, and otherwise it will give an error. So what is happening? Yeah. So we are applying standard scalar on the data set, right? So let's go. Yeah. So we instantiate the scalar to a variable. We fit the train and test data. Okay. Let me also run the code. Then we perform classification. Okay. Now, what is the classification method? So we are applying logistic regression. Let me copy the code first to you. Okay. 1 minute. Yeah. Just check if it is working properly, all properly. Huh? So LR equals to logistic regression. Then we are applying fit on the extreme norm and the normalized extreme, which came after the standard scalar, right? So that is extreme norm and Y train. So and what is Y train? Y train also came from before, right? Y train. Okay, Y train, yeah, Y train came here. Y train is the shape of the training levels 227. Okay, so on Y train and extreme norm Y train, and we are applying the classifier, which we are fitting the classifier, which is the logistic regression.
So here the score is the accuracy, right?
Yes. I think the score is accuracy. Let us check whether it is saying something. Yes, return the mean accuracy of the given test data and levels. Right.
Okay, right.
Yeah, sure. Sir. Okay. So yeah, let me. Did I paste the code here? Yeah. Anyway. So let me run also. Anyway, it is a training score is calculated to be 0.86. Okay. Acha. Now again our famous things come, which is the confusion matrix and classification report. Confusion matrix we have read before also. We'll just so how do you import from sklearn.matrix, right? We import the libraries. Then confusion matrix. Confusion matrix is again, just to remind you, confusion matrix is a summary of the prediction results on a classification problem. So we have actual class on the vertical side and predicted class on the horizontal side, right? So if it is both, if actual class and the predicted class both are positive, then what we have is true positive, right? If we have negative class, actual class to be, if we have predicted it to be positive, predicted a class to be positive, but actually the class is negative, then we have a false positive. If we predicted a class to be negative, but actually the class is positive, then we have a false negative or FN. And if we have predicted a class to be negative and the actual class is also negative, then what we have is a true negative or TN, right? And there are some important important quantities which are always calculated. We have precision, which is TP divided by TP plus FP. So TP plus FP means all the full positive column, right? The predicted class full positive column, TP by TP plus FP. Then since accuracy is there, accuracy is TP plus TN divided by all four classes, TP plus TN plus FP plus FN, etc. Then sensitivity.
So I have a question. Sorry, sir.
Sure, sir.
What is this type 1, type 2 error?
That I am also not sure. I have to check. 1 minute. Amrutha, any thoughts? What is the type 1, type 2? 1 minute. Let me go to Wiki.
Is it the same what we did in statistics in hypothesis
maybe
testing?
maybe. What did you read?
In hypothesis testing, if there is this type 1, type 2 errors which come.
What is that defined as?
No, even I don't remember, sir. But I recall we had studied something with type 2 errors and type 1 errors.
1 minute. Let us check type 1 error. One minute.
Jadev has sent something, sir.
Achha. In discourse. Type 1 and type 2 error in hypothesis testing. Once upon a time, okay, this is a long post.
It's a mnemonic to remember what type 1 and type 2 error are. So this is a story. Basically, there is a boy who keeps saying that wolf
yes,
is
exactly.
sheep. The first time, in both cases, the villagers will make an error. First, they think that the wolf is there. Second time, they think the wolf is not there. First is type 1 error. Second is type 2 error, where basically the null hypothesis is that the wolf is absent. This is the common default belief, right?
Okay.
Yeah, and when you say that the default belief is actually true, that's a type 1 error when it is actually false. And the reverse is type.
Okay. Okay. So basically
Same
these
thing,
two
yeah.
things, is it? Yeah. The false positive and true false negative. Okay.
Correct. False positive is the case where he says that the wolf is there, but it's not there. That's a false positive.
Right.
False negative is when it actually comes, they'll believe that it's not there.
Okay. Yeah. So there is a
Sir,
yeah, sure.
one request, sir. Sir, can you just paste this link also? I'll read it in detail.
Acha, 1 minute.
The
And we
discourse,
have, we have another also 1 minute. Let me see whether anything else is. Yeah, 1 minute. Huh? Prediction accuracy one anyway. Yes, everyone, whoever wants to see something, just paste here, because this is one, and this is the another blog link. Okay. So both are on the confusion. Can you check whether it is working? Just check it. Huh? So okay. So these are the two things. Thank you, Jaydev, for the good. That's a good source actually, good resource. Anyway, this image source is also there. You can check that blog also. Acha. Now again, obviously, what we are doing is we will make the confusion matrix. So from scalar.matrix, we are importing confusion matrix. Then we have class name to be 0 and 1. Okay. We are plotting the confusion matrix. What is tick marks is the length of the class names. Okay, what are the class names? And okay. So we have x ticks and y ticks. So those are the basically the graph part. Let me copy it. 1 minute. This is the confusion matrix part. Confusion matrix generation. Okay. So if we do that, we get the confusion matrix. So the true positive is 36. So 36 classes are labeled, 36 zero classes are labeled properly, and so on. So basically, and if we do a classification report also gives us the precision recall, those values, right? Yeah. So this is the classification report, which gives us the final final report, right? What is the precision, and what are the recall values, what are the F1 scores, etc. Okay. Now, so and then we print the classification report. So for 0 classes, the precision value is 0.78, whereas for 1 class, I think the precision is 0.87. The recall value, on other hand, recall value was the recall value was what? Okay, recall value is not written here. 1 minute. Let me go to the source. Recall, sensitivity, specificity, precision, accuracy. Okay, I actually also have to see what is recall. 1 minute. 1 minute. Huh? Sensitivity, specificity. So all these things we can calculate. Anyway, I'll check. I'm not finding the formula at this point. I'll just check this. So anyway, what we can generate the classification report from here, and we can calculate the precision and all other values. Now the next thing which we are going is we will do the hyperparameter tuning. We'll apply the remaining. Now the precision. Now that all the pre-processing things are over, what we have is now we are applying the randomized search CV and grid search CV. Okay. First of all, import them from scalar.model selection. Let me close the tabs. Okay. Then applying randomized CV. So we are creating a hyperparameter grid for logistic regression, and so we have a log space, log leave linear. Okay, and then we are setting up some random hyperparameter search for logistic regression. So basically, we are applying logistic regression now and fitting it with the X train normalized and Y train. Then after that, we will find the best hyperparameters in the next step, right? Let us do this part first.
So this code, can someone explain the log space from -4 to 4? What exactly are we?
Yeah, let us see whether something is there. 1 minute. So that is start, stop, num equals to it returns numbers spaced evenly on a log scale. So in linear space, the sequence starts at base to start, base to the power of start, and ends with base to the power of stop. Okay. So base is what? Base to the power of start is the base is equals to 10 here. So 10 to the power -4, it will start, and 10 to the power +4, it will stop, right? And in that case, so start is an array like, base to the power start is the starting value of the sequence, and stop is the array like, base to the power stop is the final value of the sequence. Acha. Num is the num is equals to 50. So num is, I think, the, so 20 num is the number of samples to generate. Num, so basically I think from 10 to the power -4 to 10 to the power +4, 20 number of samples will be generated. Okay, or 20 numbers of data points will be generated. I think that is the case. Amrutha, can you inform anything else?
Yeah, what you told is correct only, Debjyoti. We have a series of values for the C parameter, an array of values.
And what is C parameter? By C parameter here?
So logistic regression, right? C is of the hyperparameter.
Okay. Okay. We'll see more on it. So Jayadev, I think that that is the case. I mean, it is from 10 to the power -4 to 10 to the power +4. We are generating 20 data points. Okay.
You can copy paste that np.log space, that alone, in a code cell, and then you can just run it so that they can see what values are generated.
Yeah. Let me. Okay. Randomize. Sorry. I did not run this. This thing, na?
And that alone. So you can show them the values for C.
Okay. So 1, 2, 3, 4, 5, 1, 2, 3. So 20 values, right? Starting from 10 to the power -4 to 10 to the power +4, right? Yeah.
Okay. But what is C, sir?
C is the hyperparameter.
C is mostly C parameter refers to that regularization
yes.
parameter, right? In many, yeah. So in general, C refers to regularization value only.
Let's see whether. Yeah.
See, in the slide deck also, the parameters are listed, right, for logistic regression.
Okay. We'll see.
Yeah.
There is in scikit-learn there is a slight difference between C and alpha. Alpha is actually the lambda that we know from theory.
Oh, okay. So here it is
like actually the inverse of that. It's the
inverse of regularization strength.
Yeah. So smaller is actually higher regularization.
The smaller values of C gives you more regularization, but higher values will give you lesser regularization.
So this is 1 by
you
alpha.
meant, right?
It's 1 by lambda, yes. And alpha is actually just lambda. They couldn't use lambda in scikit-learn directly because lambda is already taken as some other variable in Python.
Okay, thank you.
And it's also not clear that all estimators will support C or alpha or what. So that has to be looked up for each separate one. So for example, logistic regression doesn't have alpha. It has C, but SGD classifier will have alpha. It will not have C.
Yeah. Okay. So once we apply that, we are seeing 5 folds for each of 20 candidates total. 100 feet. Fine. And
see, just if you want
yeah,
to
yeah.
see any parameters, no, you can just type question mark and that estimated, so we can get help from to know the parameters.
So like how? How do you write them?
Type a question mark followed by
LP.log.
the logistic regression. That is
Just
the classifier name, right? This inside this
Just
randomized
any
search
Python
CV,
function or any Python class.
anything you can
Just
type.
put a question mark next to it or before it and run that cell.
yeah, yeah.
So if
No,
in
not
case
that,
if
the
you
class,
get any,
not the object. Okay, this also works. This is allowed in OPP, I hope, right?
on the right side you can find all the
The class
parameters.
implements, yeah. The class implements regularized logistic regression using liblinear, Newton CG. Oh, acha. Yeah, this was the same things which we were discussing previously, right? So it is supports okay, only L2 and L1. So where we are at log linear, right? So log linear logistic regression. Okay. Achha, so this liblinear is what we are using, right? It implements the regularized logistic regression using the liblinear library. And what else are we looking for? Yeah, I think that's almost. And CV equals to 5, so 5-fold cross validation we are applying. Yeah, and otherwise, yeah, C is a float. It is inverse of the regularization link. Must be a positive float. Okay. So anyway, this will also you can write, you can check. And so log space, what have we completed is 10 to the power -4 to 10 to the power +4, right? After that, we are trying to find the best parameters in this in this case. So what are the best values of C? For that, I'll just paste the code firstly. So how to find the best parameters? So if we run that, we are getting these are the values of C, and for liblinear, if we take this C value, and what is the score that we are getting based on this C, and so okay, this is the code for that, and this is the score we are getting. And if we make prediction with this tuned model, we will get a confusion matrix, obviously. Let me again put the code here. Okay. So if you just predict the confusion matrix, so 36 is the true positive, and then the remaining 3 values are there. So now what we are getting is the ROC curve. ROC curve has a positive rate, true positive rate, and the false positive rate, right? So we can plot, so different character visualization parameters are there. So like that, we can check the ROC curves and all. I'll just plot and confusion matrix and everything. Okay. Now what we can do is we can apply similarly grid search CV. So previously we used to what did we apply? We applied the randomized search CV, and now we will do the hyperparameter tuning with grid search CV, right? Yeah. So if we go and we will apply, do the same thing. So we have grid search CV. We will set up the grid parameter for logistic regression. Again, the log space to 10 to the power -4 to 10 to the power +4. But here what we have done is we have calculated it to be 30, up to 30 data points will be there, right? So again, let me plot it here. Okay. 5-fold cross validation, 30 candidates, total 150 feeds. And what are the data points? Again, we can check, right? So 30 data points, 30 points are there. And obviously what we can do, we can apply, we can move through the same procedure, just have we as we have done for the randomized search CV. And we can calculate what is the best score, what is the what is this, what is the best hyperparameter and what is the score according to that. These are all for grid search CV, right? So this we have done. And the same thing as we have done for randomized CV, we have randomized search CV, we have done for grid search CV as well. And similarly, we have the confusion matrix, the ROC graph, etc., etc. Okay. And so on. Then the confusion matrix, we have 36, 4, 10, 26. What did you have previously? 36, 4, 10, 26. Okay, so the same basically. And we have ROC graph. This is also same, right, as we had done for randomized search CV. Now we are applying a pipeline. Again, pipeline is quite important for our OPPs coming upcoming OPPs, right? So pipeline, we have a standard scalar, min max scalar, max app scalar, robust scalar. All those things we can apply. So we are in the pipeline. What are?
Hey, just a second.
Sure.
Yeah, I just want to ask one question. So can anyone tell me the difference between grid search CV and randomized search CV?
So grid search will be on specific values, whereas randomized search will be on a distribution. So to select a hyperparameter from a distribution, we use a randomized search, which is continuous. But in grid search, it'll be specific discrete values.
Okay, but can you go to the code, Devjadi, once? See here in grid search CV, we are giving C the same log space. In randomized CV also the same log space is given, right? So can you go up to randomized CV?
Actually, there were 20 data points in
data point. The number of samples were increased. That's the only difference we have made. So these are the two parameters that need to be tuned, right, for C and solver. So what does it do in general?
I don't know. Jaydev will know better, but I think randomized shouldn't be like this. It should be actually
the name
something
is
from
randomized,
log,
right?
Yeah, randomized. It should be either from log uniform distribution or some distribution, Gaussian distribution. But here
see the parameters
giving...
we are giving the same values. So -4, 4, 20. The same C that you saw there. That is the range of C that are needed to be used for the model.
Right.
So in randomized, the name specifies, no, it's random. So it selects random combinations of parameters between the two given parameters.
Okay.
Yeah, for example, no, if C is
Got it.
10 to the power -4 and solver is, here we are given only one solver, we can also give the other solver names also here. Liblinear, SAG, Newton CG, other solvers also we can list here. And other parameters also we can list. So it takes random combinations of the parameters that are provided in the list.
Okay.
But whereas this grid search will give you...
Will take each and every
sample. Yeah.
Right. Which is
and
right.
yeah. So when you feel if you have a large data set or if you feel that you have more number of parameters to test, at that time you can opt for randomized CV. Because it takes mostly random combinations of all the parameters, and but one thing is it does not guarantee to give best parameters. So that is also you must have in mind.
Okay.
So if you consider the values, output values, no, best parameters of both the grid search, and it will be definitely different, I think. So can you just go to the output parameters? Where is the best parameters here?
Yeah, best parameter is here.
See, so this C value, so solver is going to be linear because we have given only one choice for solver. But the C value, so can you go to grid search? Is the same
here
or
it
different?
is 0.10. I don't think it was same. Yeah, no, 0.088.
Oh, so the parameters will be different. So these simple things you should note when you do for some applications.
Actually, what Vivek said is also partially correct. To exploit randomized search fully, it's best to make the parameters draw from some distribution. The only difference is that the same grid, if you pass to both, it will actually work. Just that grid search CV will do brute force. The other one will do random sample.
Yeah, that is what I told, no?
Yes.
Yeah. Okay. So we can continue. Just small things that you can remember, no? So that's why I just mentioned it.
Okay, thanks everyone. Yeah, let's proceed again. Amrita, can you talk a little more on the ROC curve also, if it is possible? Would you like to discuss anything?
ROC curve, the more it is on the left side, it gives you good accuracy.
Okay.
Yeah.
Anything else? I mean, like from the shape of the data, from the shape. Yeah, as you told, I mean, so if it is more on the left hand side and more like a, I mean, exponential curve, right? So then it is, it will give us better accuracy.
Yeah.
Okay, fine. And we have the confusion matrix as well, right? So ultimately, after applying everything, after fitting the pipeline, let me copy the code first. Okay. So with sklearn preprocessing, we have applied the runtime disconnected. So we will, what we are seeing is we have a pipeline of standard scalar and logistic. Yeah. So with the full pipeline, what we have is we are fitting X train and Y train. Then we evaluate the model using cross validation. And after what we are calculating is the cross val score. We are printing the accuracy of the that is the cross val score, which is the mean. Okay, and mean in percentage form. Then we are calculating the Y prediction and what is the confusion matrix. From the then we are plotting the confusion matrix and so on. So accuracy is 83.26%. Then this is the confusion matrix. We can see what is the true level and the predicted level 0, 1. And so 0 classes to be predicted true positive is 36, then true negative is 26, and so on. Okay. So with that, we come to the end of the solve with instructor. Okay. That is the end. So everyone came to this part and the code is working. I'm not sure whether this one will work because I think it may give an error. Yeah, because the fast we runtime disconnected. No, yeah, that's right. So that is we have come to the end of this part, the solve with instructor. Now the other thing which are remaining is the practice questions, right? Okay, so let's see the practice questions which are there. Practice questions, all the programming questions are using MNIST dataset. Store all the samples in X and labels in Y. Okay. All the things we have printed and plotted. Okay. Let's. Sorry. So sorry.
So that cross validation code is not working. I don't know why, but I'll check it out later.
The last one, is it? Yeah, cross val code. This was this one?
Yes, sir.
I mean, in my case, what it was doing, what happened? This one is there, cross val code is not defined.
Yeah, name cross val score is not defined. That's what is coming. Yeah.
I think we have to import it.
Import it, right.
I think so.
Right.
Yeah,
We've not imported it, right. You're right.
I think here is.
I'll do that, right.
Yeah. Just check my case also the same thing happened. Yeah. Anyway,
Sir,
let's. Yeah, sorry. Yeah.
sir, I am unable to get these code, sir? How can I get?
We are copying here in this document. Do you have the link to this document?
Sorry, sir.
Yeah, this is the link where we are this paper, right? You are talking about?
Yes, sir. Yes.
Yeah, we are writing in this document. I think you joined late. Yeah. This is the link. Can you check?
Yeah, sir.
Anyway, we will. Yeah.
How I join, sir? How I get this code? I am unable.
Sorry.
Sir, some people's name are but how to get this code?
You can click on the link in the chat.
Sir, can you send me the link?
I just now sent. Can you just check the link on the chat window?
Okay, sir.
Yeah, just check. Anyway, we will upload the solve with us. Anyway, we'll upload tonight or sometime maybe. Okay.
Okay. Okay, sir.
Yeah. Yeah. Let's go ahead with the pipe with this thing. Sorry, this one was. Yeah, this is the solve with instructor. So this we have done. Okay, we will cross it later. This part I was talking about. Let's go through the practice question once, and let us know if there is any question issue in the practice questions in the discourse. This from here starts the practice questions. This is the first part, doing all the importing part, right? So what are we importing? We have numpy as np. From print we import print, etc., etc. Then we are ignoring the warnings. Okay, fine. We are ignoring the warnings. After that, we are fetching from OpenML dataset. We are fetching MNIST 784, right? So import MNIST 784. Let me just run the collab. Oh my God, it takes so long. Okay, I'm not sure. I think this will take a long time. So anyway, then we convert the full thing to a numpy array, the x and y part. Okay, xpd and ypd is the from the data set we have imported. And what is x and y? That we have seen that all the samples are in x and the labels are in y, right? So I just write here. We are converting everything to a numpy array. X equals to x dot pd to numpy and y dot pd to numpy, right? Now the first question is, split the data set into the following ratio. Training is take the first 30 samples, store them in xtrain. Then testing is take the remaining test sample, remaining 30% of the samples, store them in xtest, right? We'll store the respective levels in ytrain and ytest respectively. So the last training sample is of which digit? Fine. How do you solve that? We have xtrain, xtest, ytrain, ytest, right? So again, this is question 1. Question 1, right? So first part is this one, xtrain, xtest, and ytrain, ytest, right? If we is that part down loaded? Everything is loaded. Okay. So what is the last sample? The last sample is again obviously from Python we know. So the last sample is -1 sample, right? The last item is -1. So then we plot the sample, and how do we print it? So the last training sample is of which digit? That is being asked. So if you just plot it, which is last sample is of digit 6, right? Now there is common data. Common data is build a classifier that differentiates digit 6 from digit 9. Build a classifier that differentiates digit 6 from digit 9. Collect all the digit 6, which is positive class. And so what are the steps to be done, to be followed? We collect all the digit 6 and digit 9 images from the extreme, stack them properly as a single data matrix, extreme 6 and 9, and keep all the digit 6 images from index 0 to I, followed by digit 9 from I plus 1 to 10. So end of I means, and so the I means the end index of the digit 6 images. All the digit 6 images from digit index 0 to I, there we keep, and after that we keep the digit 9 images. Similarly, collect the respective labels and store them in a variable ytrain 69, okay, 69, and set the label values to 1 for positive class and 0 for the negative class. So the positive class is digit 6, and the digit 9 is the negative class. Then we set the label values to 1 for positive classes and 0 for the negative classes. Load from the sklearn.utils, we import shuffle. We shuffle the data matrix and the labels. A particular random value is given to be 1729. Then we create the xtest 69 and ytest 69 by repeating the steps from 1 to 6 with the modifications. Let me give you the commands. Then starts question 2. In this case, if these are the steps to be followed, then what is the sum of all the labels in the vector ytrain 69? And what is the sum of all the labels in the vector ytest 69? How do we do that? What is the solution? We get the index of digit 6 and 9. So digit 6 index where ytrain equals to 6, and for the cases where ytrain equals to 9. Okay, fine. We get all the samples from the index array and we create the label vector, etc. Okay, and we apply the shuffle part with a random state 1729. Okay, that is the training part, training set, right? So this is again, this is question 2, U2. Okay. Achha. Then what we start is test set. So what did it ask? It asked for what is the sum of all the labels in the vector ytrain 69 and what is the sum of all the labels in the vector ytest 69. So sum of label vectors, we will calculate np.sum ytrain 69 and np.sum ytest 69, right? So at first we make the digit 6 index in this form, in the form which was told in the steps, and then we calculate the sum of the label vectors, right? So for test for training set we have done. From testing set, for testing set what we have is this one, right? And then what is the, then basically the sum of label vectors we are calculating np.sum ytrain 69 and ytest 69, right? So anyway you can do this still just for the sake of completion. Okay, and what is the ultimate sum of the label vectors for non-zero cases ytrain equals to 6 if we do. So this is the final sum of the vectors. So this was test set, then 4855 and 2021, and then we print the sum of the label vectors. So this was question number 2. What is the sum of all the labels in the vectors ytrain 69 and what is the sum of the label vectors of ytest 69? Okay. Then what happened is question 3. 1 minute, huh? Sorry, yeah. 1. So after that, what happens is we have to apply standard scalar to all the training sample in xtrain 69 and store the result in another variable, say some other variable xtrain 69 pf. What is the mean of the zero sample? What is the mean of the zeroth feature? What is the standard deviation of the zeroth sample, and what is the standard deviation of the zeroth feature? Okay, so you have to pack the answers in a tuple. Okay, so what are the what are the, so first option should be what is the mean of the sample, then mean of the zeroth feature is whether it is 0, then what is the standard deviation of the zeroth sample, that is 1 or not, 173 1 0.73 0.73 and 1.09. These are the options, and then what is the standard deviation of the zeroth feature, that is either 1 or 1, then again 0 or 1. Okay, so first of all, apply standard scalar. So we have to apply standard scalar, right? So if we apply standard scalar, then okay, we have applied standard scalar. Then we print the whatever was mentioned properly, we in the order, right? We do that. So you have mean of the zeroth sample, mean of the zeroth feature, it should be right? Mean of the zeroth feature, then standard deviation of the zeroth sample and standard deviation of the zeroth feature, right? So
I have a question here.
Yeah,
If we are applying standard scalar, then how is the standard deviation 0? Should it not be 1?
if we are
For the
applying
last
the standard
question.
scalar,
Correct. So standard deviation of a feature should be 1, right? It should not be 0.
if we are applying standard scalar, standard deviation of the feature should be 0.
Should be 1. It should not be 0. Mean will be 0. Numerically, it is actually coming out to be 0. But why would that happen? Because for every feature, when we do standard scaling, every feature gets transformed into mean 0, standard deviation 1.
Does that happen for all the real cases?
Yes. That is why we do it. So we transform everything into 0 mean and 1 standard deviation, which means that everything is coming on the same scale.
0 mean and
Mean is
standard
0.
deviation 1. So in this case, you are telling that the fourth option.
Okay, I think I'm sorry. I just figured out the mistake there. If mean is also 0 and standard deviation is also 0, which means that feature is a constant.
That is true.
And 0th feature will be top left corner of the image, right? Which will almost always be black.
Yeah.
Okay, makes sense.
Okay, just look into it. I also check. Anyway, so I'll just paste the code once. Okay. So some mistakes in the statements can be there. Okay, just look into them in this printing statements. So this was the column. So answer is option 3. 0.081 0, 0.73 then 0, 0.81 0, 0.73 then 0. Okay, so this is option 3. Okay, then question 4 for 6 points, train the logistic regression model using the SGD classifier with the following common settings. 1 minute. Question 5. Can anyone just tell me whether there were 5 questions only in the practice assignment?
Yes, only 5.
Yeah, okay, thank you.
This is week 6, right? Yes, 5 only.
Yes. Thank you, Jaydev. So train the log. Yeah, I mean, otherwise it will go into graded assignment, and we'll discuss that after the session deadline is over. By the way, week 5 graded assignment submission deadline, is it over yet, or is it yet to be over?
Oh, it's tomorrow, same as week 6.
Same. Okay, because we have to change the graded assignment questions, right? The week question 7 onwards. Anyway, So train the logistic regression model using HDD classifier with the following settings. No regularization, random state 10 and iterations to be 10, right? Capture the loss for each iteration, plot the iteration versus loss curve. For which of the following settings the iteration versus loss curve decreased monotonically? Okay, for which of the following settings the iteration versus the loss curve decreased monotonically. So set learning rate to be 0.01, plot the curve, feed the model, extrain 69. Set learning rate to be this much and feed the model with extrain 69. Achha, plot the curve and feed the model, then feed the model with extrain 69. Okay, so the learning curve is different in option A, option B. Option C says keep the learning rate to be 0.01. Okay. Scale the sample using standard scaler, fit the model with the pre-processed sample. Okay. So the new differences from option A to option C, the differences we have a standard scaler also, right? And then use the option D says use the inverse scaling strategy for the learning rate with power t to be equals to 1, fit the model with extrain 69. Answer is B, C, D. Okay. And how do you explain? So this also we have to see. Achha. Okay, so let's see.
So here also I have another question. Typically, when we do this incremental kind of training, there are two ways to do that. So suppose you are training for n epochs or n iterations, then you'll call partial fit n times, right?
Okay. Okay.
Or you can also do something like call fit n times with warm start equal to true.
Okay. Okay.
So what is the correct way of doing it?
One way. Okay.
And see, actually, what code you have written actually also adds a third option. You set max iter equal to 1, fit will always call only once. It will not call twice.
Okay.
Or rather, it will do only one pass, right? So what is the correct way of doing? Because I think it should give.
Of HDD classifier.
And of course, it's not true that all models will support partial fit or max iter also. It's not like we are only talking about stochastic gradient and related models, right? So what is the correct way of doing that? So is this equivalent to no max iter equal to 10? If I said that will be wrong because it might converge before 10 also.
I think where it converges after seeing that value only we can check. I'm not sure. I mean,
I'm asking from the perspective of say OPPs or the way that we have.
I think in OPP it will be informed what you have to actually do. Otherwise, can you just post? I have to ask around actually. I'll just ask and check the books. Okay.
Correct. Basically, the question is simply this: that to do incremental training, there are many different ways. Is there a recommended best practice or something? No, not optimized. Just optimized way would be to just set max iter equal to 1000 and leave it.
Okay.
Then it will internally figure out what to do. But what we want is we want loss at every epoch, right?
Yeah. Obviously.
Right. So to do that, there are multiple different ways. What is the best practice or the correct way? That was the question. I'll post it somewhere.
I'm not sure. Yeah, just post or if you post there, can you just tag me? Otherwise, I also have to find it. Just tag me. I'll ask around. Okay.
I'll do that. So basically, as example in this particular exercise, I did partial fit. And max iter I ignored completely. Anyway, it is whatever you're doing partial fit only once it will ignore max iter. Right. And I got the same result. So getting the same answer is possible through many different ways.
I think that is the one which you posted now once. You were seeing something like that. Is this problem you posted once?
No, I have not posted anything about this particular problem.
Okay, I think something is I missed. Okay, sure. Just let us know. I have to actually check with the people who with the person who made the question. I'll check once. I'll answer. Okay, I'll get the answer.
All right, thanks.
Yeah. Just post and tag me. Anyway, I'll plot the 4 options here, the codes here. So this is the first option 1, right? Option 1. If you do that, then we have a loss decreasing like this. Okay. for which of the following settings so the loss will be decreasing monotonously, sorry, monotonically. So here it is obviously not decreasing monotonically. In the next option, yes, monotonically decreasing. So exponentially actually decreasing. So let us see, we have L2 penalty, maximum iteration to be 1, worm start to be true, eta not equals to 0.00001, whatever be the case. And then if we plot the loss, this is option 2. This is option 2. There you have the exponential decrease. For option 3, on other hand, again you have a almost knee curve like structure, right? So there also it is exponentially decreasing compared to the option 1. So there also it will be option 1, option 3 will also be correct, right? So basically in MSQ, if you go to option 3, sorry, this is option 3, what you have is this one, right? So then the next option is option 4, where also again if you put a SGD classifier with log loss and L2 penalty, maximum iteration to be 1, and what else were they asked in the, what else? Inverse scaling strategy for learning rate, power T to be equals to 1, fit the model with extreme 69 without any pre-processing. Okay, so it should be option 4. Option 4, where is option 4? This is option 3, this is option 4, right? So what we have is again a graph between linear and exponential kind of structure. We have learning rate to be inverse scaling and random state to be 10. We did not apply any we did not use X69 TF, right? We did not use, sorry, not X69, we did not use any pre-processing here in option 4, right? And so what have we got is on the extreme 69 we just plotted, and if you run, I'll just paste the code again. Okay, this is option 4. Option 4. This is the structure, right? Then also we are getting a graph like this. So with iteration, the loss is continuously decreasing and there is no up or down. Okay, so the loss continuously decreases in BC, in all the 3 options, B, C, and D. Therefore, all of them are correct options. Then comes question number 5. To train the logistic regression model using SGD classifier with the following common settings: no regularization, then random state to be equals to 10, iteration to be 30, capture the loss for each iteration, plot the iteration, again plot the iteration versus loss curve, for which of the following settings the iteration versus loss curve converged quickly to 0 loss. Basically the similar thing. So we have set the learning rate to 0.01, we plotted the curve, fit the model. So for all 4 things we have to do. And but here the answer is A. So we have A, option A to be learning rate 0.01, plot the curve and fit the model. Option B has learning rate to be 0.000001 and extreme 69. Keep the learning rate as 0.01, scale the samples using standard scaler, that is option C. Option D says to use the inverse scaling strategy for the learning rate with power T to be equals to 1. Okay, so again, so this is question number 5, right? Question number, just question 5, right? So question 5, first we will start with option 1 or option A, whatever be the case. Enter the iteration number for which the loss becomes 0 and remains 0 for the rest of the iteration. Achha. Yes, so we can see that here I think after 10, 11, 12, 13, 14, At 14, you can see that the iteration becomes 0 and remains 0 after remains 0 for the rest of the duration, right? So if we just plot here, so this is the first option which we are doing, right? And we have estimated to be SGD classifier, and whatever it was, log loss, plot set learning rate to be 0.01, right? Okay. Okay. Okay, fine. And for option 2, the similar thing. Option 2, what we have? Option 2, we had set learning rate to be 0.000001. Fit the model with extreme 69. Okay. There it actually it decreases. So what did they ask in the question? In question, they asked for which of the following settings the iteration versus loss curve converged quickly to zero loss. Okay. So the loss became 0 at 14 in the option A. But in this case, if you see here also, it did not decrease up to 0. Like it did not touch 0. It became an asymptote kind of thing in option 2. Let's see what happened in option 3. Option 3 also did not touch 0, became an asymptote kind of thing. And what about option 4? Option 4 also again did not touch 0. So only option 1 is touching the 0 value here. Anyway, let us solve the let us do the codes for all of them. Okay. So anyway, you can see this is the option 1. For option 2, this is the code. If you write it, this is option 2, right? If you write this, it is again, if you will see that the loss is never touching 0, maybe almost equal to 0, right? 0.001, but not exactly 0 and not staying 0 at any point, becoming like an asymptote. Compared to the obviously, then again, question number option number 3 also the same case. Okay, we have a exponentially decreasing value, the exponentially decreasing curve. Okay, I mean, not even exponentially, it's very much like a knee curve. It's like a diode anyway shape. So anyway, iteration versus loss will almost touch 0, but never touching it, becoming an asymptote. So this way you can check. So 1 start equals to true, eta naught equals to 0.01 and alpha to be 0. Learning rate constant and random state was just to check the correct value. So learning rate will be constant again. Option 3 is this one. Okay. And so then there will be option 4. Option 4 is again the same way. Just decrease the curve of the rate of decrease, loss decrease is a little low, maybe. I mean, not at the very beginning it is decreasing, but just decreasing, I mean, very slowly. Okay. So this also you can do by putting the learning rate to be inverse scaling, loss equals to log, the penalty equals to L2, and so on. Okay. And so that is our option 4. So from all of them, what we get the idea is that what we get to see is that only in question number 1, option number 1, the up to 14 it has come and became 0 after that. Did not I mean, it could not reduce after below 0. But in all other cases, it never became actually 0, right? Became always an asymptote to the 0 and stayed that way. Okay. So that's what the practice questions are. Okay. So mostly those are the things I wanted to show. Anything else, anyone? Okay. Okay, so in case anyone has any other doubt, just post in the discourse, tag either me or Amrutha or Anamika, Jimmy, Swarnim, Sony, if you want, okay. I think we up to week 7 I am taking. Amrita, you want to say something? Yeah. Anyway, so up to week 7, I think I'm taking. After that, someone else will be taking. So, and let us know about the. So this one, the practice question, I'm not sure whether I can upload right now. But anyway, you have the codes, and the solve with instructor will upload today, or I mean, whenever the office opens, I think maybe within Monday it will be uploaded. Should be uploaded. I'll send it. Anyway, that code also you have. Anything else you need from week 7, just let us know in the discourse. We'll post it. And yeah, that's it, I think. And the next you should start preparing for OPs. OP, the topic is week 1 to 4, right? The same topic you give for quiz, and that will happen in the end of this month, right? Okay.
Right.
Yeah. So we'll.
Thank you,
yeah,
sir.
Yeah. Yeah.
Thank you, ma'am.
We'll end here. Amrita, any other comments? Anything you want to say? Anything?
No, David, fine.
Okay.
Thank you.
Yeah. So everyone have a nice weekend.
Yeah.
We'll meet again next Tuesday, and yeah, we'll discuss something more. In case anyone needs any details, just let us know in the discourse. Okay. And yeah. So learn some other strategies also. I mean, the Kaggle competition is coming. We will also upload the. I mean, I think they are discussing on what to say, and I mean what data set to arrange, and what to give and all. So learn basics of Kaggle, and there is the Titanic data set, which I think the primary, right, the preliminary thing. So it will be helpful if you just go through how it is done. So again, I mean, there was a very famous course on Coursera on how to win Kaggle competition. I think Ashish sir was also telling us some day back. But it was from Russia, and so right now that course is not offered by Coursera because of the the recent wars and everything. But the GitHub codes of that Kaggle competition is still there. So if you can find it, it will be great. Okay. If required, we will also try to put. But you can check. I mean, it was a good course. I heard. I have not also done, but sir was telling that it is a nice course. So if possible, try to see that in Coursera. It was on how to win a Kaggle competition. So try that in GitHub. You can see whether their lab notebooks are there and course notebooks are there. Yeah, mostly that's all for today. Okay, so let's finish it here. We'll meet again next week.